I'm going to introduce Mikey Siegel. He just finished his MPhil at, actually a year ago, right?
2 years ago.
2 years ago at MIT. And then now he's he's interested in kind of transformation in technology, a lot of the recovering creativity type stuff and the work that we're doing on media psychology and everything. And so hopefully we'll have him around for at least a year or so, try to get him to come settle in Hong Kong for a little bit. And so, with that, he just flew in, live from, just, in from Los Angeles. I'd like to, here's Mikey.
Thank you guys. It's a pleasure to be here. As Gino said, I'm going to make an excuse right up front. It's 3:23 a.m. for me, but you guys are so exciting that you're going to energize me, and it's going to be no problem. So, as Gino said, the title of the talk is Persuasive Robotics, How Robots Change Our Minds, and it's going to be a little bit of an overview of just the general area of robotics that I was working in and that my group at the MIT Media Lab, the area that we were working in, and then I'm going to dive into some work that I did for my thesis, and then a project that I did in a research position that I was in at the Media Lab after the thesis time. So let's get started. So here's the little background section. This is kind of early days where I got started. I did my undergrad at UC Santa Cruz, and this was kind of leading me up to the area of robotics. This was some stuff in the area of multi-robot path planning, and then interestingly, I put this in because Gino was excited about it, so I had to put some pictures. We did a project where we actually tracked elephant seals, which are the second deepest diving marine mammals. So we looked at tracking their environment and their behavior over a 6-month period. But I went after UC Santa Cruz, and that's when I started to get a little more to this robotics stuff. So this is still not quite the kind of robots we imagine, but this was a panoramic imaging system, which I worked on, which actually turned into a commercial product. So you can actually take these super high resolution multi-gigapixel panoramas, and the system will automatically take the panoramas for you, and then on the computer end you can stitch all the images together, so you can take these unbelievably high resolution images. But it was after that, again at the NASA Ames Research Center, this is in Northern California, this is when I really started to kind of get some experience with robotics. This was a human-robot interaction project. You can see this is me in the spacesuit, which the only interesting part about this was that I got to wear this spacesuit for Halloween, which was awesome. It was the best Halloween costume. Can you hear me without the microphone?
It'll record.
Oh, it will record. Okay.
If you don't mind.
No, I don't mind. So then from the NASA Ames Research Center, I ended up at this place. This is the Robotics Lab at the MIT Media Lab. A really cool place if you guys ever get the chance to visit. And so the larger area that we were focused in was this area called human-robot interaction. It's kind of what it sounds like. It's all about humans interacting with robots, right? It's like human-computer interaction, except computers got arms and legs. And the specific area within human-robot interaction is called sociable robotics, or a sociable robot is what you would have. And it's kind of what you would imagine. It's the way that Cynthia Brazil, who was the advisor at the time, she started this group, the way she defined it, social robot is defined as participating in social interactions with people in order to satisfy some internal goal or motivation. So she's talking about it sort of from the perspective of the robot. This is what the robot is trying to get out of the interaction. Another way of thinking about it is that the machine becomes less of a tool, so it's not something that you're using for some end, rather that the robot is a partner in some process that you guys are going through. So another way of phrasing it. So a perfect example of this is, I don't know if you guys, were here when Corey Kidd was teaching a class? So this is actually a robot that a guy named Corey Kidd is building at a company in Hong Kong, and he started this robot in our lab at the MIT Media Lab, and it's a robot for weight management. And the reason why it's a perfect example is because the entire functionality of the robot is based around its ability to interact with people. So the whole premise is that through this human interaction, it's able to change your behavior and foster better eating habits and better exercise habits. Well, if it's not engaging, if it doesn't provide you with a fulfilling and successful interaction, well then it's not functional. Unlike, let's say, another type of robot like this, here's human-robot interaction, but the function of the robot in this case is probably defined as picking and placing objects or working in a machine. That's its function. The human-robot interaction here is probably just to make sure it doesn't chop anyone's head off, right? So that's not really tied to the function. Again, the Roomba, it has human-robot interaction and you have to push the buttons, but its function is cleaning the floor. Its function is not tied to the actual interaction with the people itself. Here's a gray area, right? So this is a human-robot team doing a mock exploration. Well, in this case, the function of the robot might both be dependent on the interaction with the people, but might also have an external function of testing rocks or something like that. So it's not as if it's black and white. One of the people that really laid the groundwork for understanding how this kind of human-robot interaction makes sense is this guy Cliff Nass at Stanford, and he wrote this amazing book which essentially lays the groundwork for the idea that fundamentally people treat new media, whether it's robots, I don't know if you guys are familiar with this guy, whether it's robots, your cell phone, computers, fundamentally at a level that's not conscious, right? You're not aware of it. You fundamentally treat these things as if they're people. I have an example.
Huh? Fast bit. Get on. He's not doing anything. Can you get up? Yeah, this is good. This is a good test.
So I watch your faces. Half of you are cringing, and many of you are making outright noises in watching this robot. It's a machine. You're watching it being mishandled. You wouldn't make those noises if it was a toaster, right? And that's all it is, just a toaster, right? With some skin on it. But the reason why you respond to it in that way is because you have it has this social component, right? It's making these sounds. It has these organic movements. You're drawn in, right, to the story of this robot, right? And this is part of creating an engaging experience. So how does persuasion tie into this? First, we'll start with the definition. Persuasion involves one or more persons who are engaged in the activity of creating, reinforcing, modifying, or extinguishing beliefs, attitudes, intentions, motivations, and or behaviors within the constraints of a given communication context. That's a real mouthful. We can just limit it to modifying beliefs or behaviors. It's a good working definition. It's a nice way to simplify it. So really what we're talking about is something that is fundamental to really human interaction, and if you want to create human-robot interaction in a social context, persuasion should be a part of that as well. So persuasive robotics is just applying this concept of persuasion to human-robot interaction. So why would we want to do this? There's a couple different reasons. From an HRI perspective, as I just said, if you want to create robots that fluidly exist in a social context, they need to play by social rules. They need to have that tool set that we have as people, and part of that tool set is the ability to engage in this kind of active modification of other people's behavior and attitudes. Another side of it is it's necessarily true that not just robots, but computers and other forms of intelligent media will change our behavior. It's not a question of being lucky and making it happen. It is already happening. So if you don't understand the mechanisms behind which the tools, the things you guys are already creating, if you don't understand the ways in which they're already changing human behavior, then you're essentially, creating in to a certain degree in ignorance. Potentially creating, perhaps a dangerous situation or just a situation you didn't intend, a consequence you didn't intend. So the other side of it is the functionality of a social robot is actually tied to the way in which people perceive and respond to them in a social context. This is not true, as I was saying before, with robots like this, where the social interaction is in no way connected to its ability to socially interact. So now we want to explore these ideas, okay? So what we decide to do is create a study where we look at the way in which people interact with this awesome robot that we have in our lab. And so we convinced these folks at the Museum of Science in Boston to let us use their facility there. And over about a 3-month period, we end up running a study of about 350 people. And the robot that we use for this study is this robot. It's called the Mds Robot. And MDS stands for Mobile, Dexterous, and Social. This is sort of the centerfold view of the robot. So the mobile part comes from the fact that it has this mobile base that allows it to move around. The dexterous part refers to its hands. It has the ability to grasp and manipulate objects. And the social part is this expressive ability. And again, it's this expressive ability which, in this case, defines the robot as being social. You can have hand gestures, and that can actually go a long way, but the ability to show emotion is this sort of non-verbal form of communication is pretty fundamental to this kind of social interaction. This is a little video overview of the robot.
Hello, my name is Nixie, and I'm an MDS robot. MDS stands for Mobile, Dexterous, Social. Mobile because I can move around. Dexterous because I can use my hands to touch things or even pick them up. And social because I can communicate in many of the ways that people do. I can tell you that I'm sad, mad, confused, excited, or even bored just by moving my face. But I hope you can see that I'm very happy to have met you. Thank you for visiting me, and I hope to see you again soon.
Just a word of advice, never have your girlfriend do the voice of the robot, because you're going to hear it for the rest of your life. So this is a view of the inside of where we held the study. It's called Connor's Computer Place, and it was this sort of happening, fun, exciting place at the Museum of Science where people would go and they would learn about computers, and they had different little robots and things like that there. And we had a space set up inside of this area. It was sort of closed off. We had curtains all around. We had kind of tape marking where people were standing. We tried to control as many aspects of this study as we could, so that every time people came in, they had a very consistent experience. And the only things we would change are the things that we wanted to measure the effect of. So in this case, see this white box over here? That was, back up. So we measured a number of different things in this study. Some of the things we measured included, see how the robot is shaking the person's hand? So we measured the effect of what happens when a robot shakes your hand, right? You keep everything constant. You have people coming in day after day interacting with the robot, but for certain people, the only thing you change is the fact that the robot shakes your hand. Another thing that we changed was how close people stood to the robot. So interpersonal distance is considered to be a factor in persuasiveness. So how close or far away you stand from a person will change, in taking into consideration other variables, how persuasive that person is. So these were the kinds of things we changed. I'm going to go into that in a little more detail. But there are the things we changed, and then there are the things we measured, right? So we have these variables like handshaking, interpersonal distance, and I'm going to talk about some more in a few minutes. But in order to understand what effect these variables have, we have to measure it in some way. So the measurements we use, one was money. It was donation. So if you look in this slide, there's a white box here. This was the donation box. And before people went into the study, they received 5 $1 bills, real money, green, good American money. And they had the option of donating 0, 1, 3, 5, however much, or none, or all of the money that they wanted. And the reason why we chose this real money measure is because money has very real significance. Once it's in your hand, you don't want to give it up. It has real meaning for you. You can put it in your pocket and keep it and buy something later. The other measures that we used were in the form of a questionnaire that the subjects would fill out after the study. And these are subjective measures, right, where the person is sort of giving their opinion. And these subjective measures were how trustworthy they felt the robot was, how credible they felt the robot was, and how engaged they felt the robot was. And for each of these measures, there would be a whole bunch of questions that would sort of tackle little aspects of that measure. So for trust, there might be 12 or 15 questions just around trust. And these are standardized measures that are used specifically for these things, used across the social psychology discipline. So I didn't make up the way in which you would measure trust. So I said that some of the things we measured were touch and interpersonal distance, but one of the other things we measured was robot gender. So one of the interesting things about robots is that you can change fundamental aspects of them. And this is true with computers and phones. A lot of this new media that we have, which is something you can't do with a person, right? So it's one of the unique properties of a robot. And all you have to do in this case, because this is a somewhat androgynous robot, all you have to do to change the gender is change the voice. So we had a female voice robot, which is the voice you heard, and then we had a male voice robot as well. And that was totally convincing to people. So in addition to the male and female robot, we had, of course, both male and female subjects interacting with the robot, and it turns out that it actually mattered a lot whether or not the subject was a male or female, they responded totally differently. It actually turns out that more or less what we found is there was this cross-gender effect where men tended to respond more positively towards the female robot, and women tended to respond more positively to the male robot. But really, if you look a little bit closer, you find that the response was much stronger in terms of men favoring the female robot. Women favored the male robot, but not to such a great extent. But men really, I don't know, had this amazing preference. It was a big deal. So it gets a little more interesting also. I don't know if you remember from the pictures you saw, but during the study, when people would interact with the robot, they could be alone, or if they had friends or family with them, they could actually participate in the study with their friends or family standing behind them in the same room. But they were still there in the room and they were watching the whole interaction. Well, it turns out that men, it didn't matter if they were alone or with other people. But for some reason, it turns out that women, it did matter. So when women are alone, they have this tendency to donate more to the robot of the opposite gender. And this also holds true for credibility, engagement, and trust. All these things ended up being correlated. I should have, that's an important point. I'll say it again in a minute. But when women are in a group, they switch their preference. So somehow the influence of other people being around them actually causes them to donate more to the robot of the opposite gender. So looking at the touch condition. Now, it's easy to imagine touch is a very fundamental part of human interaction, but also you can imagine for persuasion, you can imagine like the car salesman, right? He's going to try to shake your hand right at the get-go. It turns out that the effect of touch actually acts to reverse this cross-gender effect. For some reason, when touch is involved, all of a sudden, men donate more to the male robot and women donate more to the female robot. So there's a lot of reasons why this could have happened, and I almost I try to avoid going into those details in a talk like this. I'll write about it in papers and stuff and cite sources and go through and look at other studies where this person found this and this person found this. But there's been so few studies like this with humans interacting with robots that it's almost silly to try to come up with a reason. I think at this point, the most interesting part of this is just the idea that these seemingly subtle aspects of the robot's character, right? Something like the robot's gender, or something as simple as how close the robot is to you, or whether or not it shakes your hand, can fundamentally alter the nature of the interaction. And I don't think this is just about robots. I think this holds true for, especially true for any kind of avatar you have that has some kind of social interaction on screen. But it's true for really any kind of interactive experience. And this just highlights that. So it's just something to consider when you guys are going, to design some kind of interactive experience. So another project that I want to talk about is a collaboration that we did with Audi, the car company. So this was after the thesis, so I was sort of excited about these ideas of the power that this social interaction could have over changing people's behavior, and decided to look at this area of driving safety and ask the question, could we apply some of these concepts to this issue? It turns out that, for example, I think people from the ages of 16 to 22 in the United States, car accidents are the #1 cause of death. And as you grow older, death by car accidents remains in the top 5 or 7 #1 causes of death. I mean, a lot of people die or get into accidents in automobiles. So it's actually it's a huge issue. And the way that driving safety tends to be addressed is by creating new anti-lock braking systems, or putting seatbelts in the car, or creating laws around seatbelts, or something like that. The fact is that most accidents are not because the road was icy or because the tire popped or something like that. Most accidents are caused by some repeated behavior that the driver would have done a number of times and would have received what you could call a false positive reinforcement, where because they were texting while driving and they didn't get into an accident, they decide at some level that's okay. So they do it again. They text while they're driving. And they decide, oh, I didn't get into an accident again, it should be fine. So they do it a number of times. What they're actually doing is increasing the likelihood that they're going to get into an accident ultimately. Whereas in their mind, the opposite thing is happening. So they're forming a bad habit that's continually reinforcing itself. So the idea is, can you actually make the driving experience safer not by making the car safer at a physical level, but by putting better airbags, but can you make the driving experience safer by making the driver safer? So then you have this question, well, how can we most effectively change driving behavior? How do we change the way that drivers drive? And the idea is, what if you could put a social interface, a persuasive social interface, inside of a car? We already have this idea that these kinds of tools can be useful for changing people's behavior. Could this work inside of an automobile? So we came up with some different concepts that are pretty funny. So here's one. So we're really just kind of exploring. These are just like playful explorations into this space of how can you take existing systems in the car and add some anthropomorphism to them. So, the earlier example you saw was eyes. This one on the left is a little more abstract. So it was Audi, right? So we have the Audi rings. This one is more like from 2001, Space Odyssey. Oh, this is my favorite. So the idea, this is where we started getting to this other space. So the idea here, I tried building this. It was a lot easier to do in the animation. Was that you could have this interactive component to the car that literally would disappear when it wasn't in use. So the dash would look completely normal until the interaction was appropriate, and then the dash itself could deform. Now what we ended up going with was something that seems a little crazy. So here's some concept drawings kind of leading up. I'm not this good of an artist. I didn't do this. So what we ended up going with was kind of riffing on this concept of something that's completely flush with the dash when it's not in use, but something that could, I think this, yeah. So something that actually can kind of like show expression and sort of be flush with the dash, but also kind of come out of the dash. And the idea here, is not that this would go into a production car, like you wouldn't want to have this on the road with you while you're driving, but that this would be a research tool in a driving simulator to start exploring these concepts of how would it change the driving experience to have this social element in the car. Oh, that's good. We should watch that. So the the nice thing about this concept was you could have these tiered levels of interaction where it could show these expressions completely embedded in the dash, or it could sort of lift its head up a little bit, or it could emerge completely. So in the process of doing this research, you could explore different modes of interaction. So here, if it works. There it is. So this is, it's just going through like a cycle of different kind of silly expressions. So we actually had an embedded laser projector inside the head of the robot, which was kind of cool. So that's how we got this effect of having this, because the front is actually a curved surface. So that was where I left the project. So the idea was that they would take this concept, it was embedded in a dash, and that a driving simulator would be built around it, and that we could start exploring this idea of how could you change the way in which people drive by having this social entity within the car. And that's it. Are there any questions? Yeah.
I love the robot in the car, the project. Is this the demo or when this project is launched?
Oh, it's a good question. So it was a 3-year project, and I did the first year of it. And so where I left it is I had sort of defined the rest of the progression of the research project, but I don't exactly know where they ended up with it. So I would imagine it's still, in a lab at MIT, some grad student poking at it and doing stuff. But I think the idea has value, and I hope Audi was excited about the concept of it. And I don't think it makes sense to have this moving thing in the dash, but to have this social interaction as part of the driving experience. I think that they were talking about adopting some part of that.
Hang on a sec. Let's get down.
You mentioned that the system can recognize whether people is doing something wrong while they're driving. Is there some sort of camera which capture the human's body movement so that it could recognize they're doing something wrong? Is that something like that?
Yeah, so as I said, the system was never implemented in a car. We did have a camera that could recognize, where you were looking and could recognize general orientation of your body. But a lot that would be required in order to recognize those types of driving behaviors are already a part of the car. So if you have a camera that can look at gaze and body orientation, and then combine that with the in-car sensing systems, so looking at acceleration and deceleration and how fast you turn, and even now with newer cars, they can actually detect where lanes are, how close you are to cars in front of you or behind you. So all of these systems are already part of cars. So you can get this feeling for when people have these abrupt stops, or when they're tailgating a car in front of them, or when they almost change lanes but there's a car they're about to hit and then they swerve back. All those things can be detected with existing systems. Yeah.
Testing. Oh, okay. I'm wondering if you, just like the example you just showed us in the social interaction robot, before you developing this kind of robot, what's your original idea? Because from your presentation, I recognize that you may put your point on the human side, because interaction has two sides, human side and the system or robotic side. You put the point to the human side, so that's it, right? So before you developing this robot, the social interactive robot, you just first consider the factor of human, or just like what kind of social interaction does the human really want, or another side, what kind of robot you want to develop.
Yeah, it's a good question if I understand it correctly. I think we were sort of looking at it in terms of, I guess, the bigger picture or a really narrow picture, trying to understand more of the fundamental building blocks of this human-robot interaction, upon which you could then look at a particular application. So let's say you wanted to have a robot in a hospital setting, delivering medicine or something like that. Then you'd have a particular application, in which case you'd want to look specifically at what is the best robot design for that application, what does the user need in that application. And for example, in this situation, let's say it turns out that everything I found in this study holds true for every robot ever. So in that case, you may say, okay, well, when the robot goes in to deliver medicine to a female patient, then the robot should take on a male persona, right? Because then the robot would seem more credible and more engaging. When the robot goes to deliver medicine to, a male patient, the robot should take on a female persona. So, does that answer your question at all? This is more just, these are the building blocks upon which you would then define an interaction. Did that answer your question?
Yeah, thank you.
Okay. Any other questions? Cool. Well, thank you guys very much.
All right, thank you very much. I don't have any announcements or anything else for tonight. So,